Alright, the subject at hand here is hemoglobin saturation, actually partial pressure of oxygen with hemoglobin saturation, as well as hypoventilation, hyperventilation, and how that affects the saturation curve. Um, Basically what you have here is you have hyperventilation, which means that you're breathing too much basically, and therefore you're going to have an increase of oxygen in your bloodstream and a decrease in CO2, partial pressure. And also you have hypoventilation, which is where you're not breathing as much as you should. So what happens is you get a buildup of carbon dioxide in your bloodstream, and you have a decreased partial pressure of oxygen in your bloodstream. And with hypoventilation, when you breathe less, basically your cells need to release carbon dioxide. That's what we do. It's a byproduct of cellular respiration. So with hypoventilation, that CO2 is slightly acidic. So an increase in CO2 makes your bloodstream more acidic, which means you have a decreased pH. And with that, with an increase in acidity, decrease in pH, you will have less partial pressure of oxygen bound to hemoglobin. And so basically the dissociation curve would move to the right. The dissociation curve can also come into terms with temperature. If you have an increase in temperature, you have a decreased affinity for oxygen saturation to your hemoglobin. So it would also be a curve to the right. As far as curves to the left go, which means that you have a higher affinity for oxygen binding to hemoglobin, you will have hyperventilation, which increases your O2 concentration in your bloodstream. So therefore, that would increase your pH, which would mean it would decrease your acidity, which would cause cause oxygen to bind to hemoglobin more readily. Also, if you decrease the temperature, the curve moves to the left, which means there's a higher affinity of oxygen to hemoglobin. I think that pretty much covers it all for that subject. Something to remember for all your science courses.